In this video, we want to try another definite integral example, but at the same time, I also want to unpack something dealing with something that happens occasionally where we get actually negative area. And I know that's a weird concept because typically we think of area as always being positive, but I'll explain what I mean in just a second. So this looks just like any other example, definite integral from 0 to pi over 2 of cosine x dx. And so if you want the integral from 0 to pi over 2, we very well know that this means the area under the curve from 0 to pi over 2. So I know how to do this. I know the fundamental theorem of calculus. It says take the antiderivative of the cosine function, which is sine, and then I'll put my bracket with a 0 and a pi over 2, and then I'll plug in b and plug in a, and I'll subtract. So a little quick mental math here. The sine of pi over 2, if you think about your unit circle. And as a little side note, for all these trig integrals, especially the definite integrals where you're plugging in values, man, you really have to know your unit circle well and be able to evaluate trig functions at pi over 2 and 7 pi over 6 and pi over 4 and all those different radian values. So if you don't know your unit circle very well, it might be worth your time to go back and freshen up on that a little bit. But nevertheless, sine of pi over 2 is 1 and sine of 0 is 0. And so I'll write those two quantities down and I'll subtract them. And the answer is 1. Now, what does 1 mean? Well, if you recall, this definite integral gives you the area under the curve. So the area right there in this little portion is 1. But we're not going to stop there. I'm actually going to do something else as well for this example here. This was just part A. Let's move on to part B. Same problem, and I want to look at the integral from 0 to pi of the cosine function. Now let's look at this for a little bit. Here's 0 and here's pi. For the first half, it's above the x-axis, but for the second half, you can tell it's going to dip below the x-axis. Now, let's just make an educated guess here. What do we think is going to happen? Are we going to get a total area of 2? Somebody might argue that. Since this has an area of 1 and this looks somewhat symmetrical, maybe 1 and 1 make 2. Maybe they cancel out. Maybe this is positive area and this is negative area. Who knows? Let's do the math and see how everything plays out. So here we go. Same antiderivative. It was the sine function. Bracket with a 0 and a pi. Sine of pi on the unit circle is 0. Sine of 0 on the unit circle is 0. And 0 minus 0 gives you 0. Now this is a weird answer because I thought that this was supposed to give you the area under the curve, and clearly there was lots of area, right? And area can't be negative. And so what happened to all this area here? What was it that went on? Well, you in fact, in this situation, you can have negative area. And the first time students hear that, it usually rubs them the wrong way because they've always been taught their whole life area is only positive. You can have only so much positive square feet, or you can only have so many positive square inches, or whatever the situation may be. But in fact, for this example, you can treat this quote unquote area as a negative quantity, and I'll give you an example of how. But for now, what's happening is this was a positive 1, and this amount down here was a negative 1. And so together they negated each other, giving us 0. All right, now let's answer this pressing question. Negative area, how does this even work? What does this even mean? For this, let me give you an example, actually. Let's say we owned a business, and as we all know, businesses can have profits, or should have profits. That means that they're making money, right? They're making money. So as the months go on, let's say, you started off a business, and maybe after the first month you had a profit, and then right off the bat, before, you've been in your business too long, let's say something happens bad, the economy goes bad or whatever. We all know that you can have months as a business where you in fact don't make a profit. Your business might even lose money. So if you just broke even, that means you didn't have any profits, but you didn't lose any money either. But let's say your business was so bad over the next couple months that not only did you not make any profits, which would be like right here on the x-axis, but you actually had you had losses, you had negative profits, if you will. And so that makes good sense in our minds. And let's say this happens for the next couple months, and then let's say after a couple months the economy picks back up or whatnot, and then you break even, during some month in the future or whatnot. All right, if we took the integral of this function on the interval from a to b, what would we get and what would it represent? Well, the first little part, you'd get a numerical value from here to here, that's representing this positive area. And so if this b stopped right here, we would have positive profits. This is the totaling of the profits throughout the first month or two. But if you look down here below the x-axis, this is all the months that you were steadily losing money. And notice the yellow area seems larger than the blue area, and so this net result will certainly be negative, indicating overall, over the first 6 months or 8 months or 12 months or whatever it is, our business has lost money. Now, have we lost this much money? Not exactly, because it's been canceled out at least a little bit by the positive amount that we made. So if I were just to make up random numbers here, let's say during the first month or two we made $2,000, but over the next few months we lost $10,000 or something like that. Then the net result would be negative $8,000. And so if you computed the integral from a to b, this would equal negative 8,000, and that makes perfectly good sense in our minds, understanding this in like a business perspective. In the same way, you can apply this to physics type examples, biology, chemistry, any real realm of life. The idea of having negative integration, negative integrals, makes sense. So don't be afraid if your answer is a negative. Now, I have students that ask me a lot, well, Devin, do I have to know what the graph looks like so I know what to make what negative, or when to make what negative? And the answer to that is no. The math takes care of everything. You don't have to know when the function's above the x-axis or below the x-axis. It's not something we have to concern ourselves with. The math plays that out. And we saw that play out here where we got a net result of 0. Let's finish up with one last example, and this will really explain this here. And we'll make an educated guess on the answer before we even start. Same integral, cosine x, but we're going to integrate from 0 to 3 pi over 2. Okay, so here's the cosine graph, and here's 0, and here's 3 pi over 2 back here. So we're going to integrate from 0 all the way to 3 pi over 2. So we're going to get this net area here above and below the x-axis. Now tell me, what do you think the final answer is going to be? Or at the very least, what do you think the sign of the answer will be? Hopefully you said negative, because it looks to me like there's more negative area down here than there is positive area up here. It just looks larger. Okay, so let's see if we can do the math here. So let's see, we'd have integral of cosine x would be sine x, bracket with a 0 and a 3 pi over 2. Sine of 3 pi over 2 on the unit circle is negative 1. Sine of 0 is 0. We subtract them and we get negative 1. And so in fact our answer was negative 1. Now a couple of you could have even given me that specific numerical value just based off of symmetry and whatnot. Because if you look, it looks like, let me change to a yellow here. It looks like these two portions right here would have canceled out, this portion here and this portion here, because they look symmetrical, leaving you only with this part at the end, which would have an area of 1, just like the original problem had. So, but it would be negative because it's below the x-axis.